Hi, my name is Jennifer, and in this video, I'm going to show you how to simplify square root expressions. So grab a pencil and some paper and work through these examples with me. Take a look at these numbers. I have 1, 4, 9, 16, 25, 36, and on. Do you recognize these numbers? These are perfect square numbers. That means they're the answer to a multiplication problem where it has a number times itself. For example, 1. This is the answer to 1 times 1. 4 is the answer to 2 times 2. 9 is the answer to 3 times 3, and so on. So in this video, I'm going to show you how to take the square root of numbers. The square root symbol is drawn like this. It's also called a radical symbol. So for example, if I were to choose any of these numbers, I would put that number under the radical sign, and you would say this problem, what is the square root of 16? It's asking, what was that number when you times it times itself produced 16? For this problem, that number was 4. So the square root of 16 is 4. Let's try it again. If I put 36 under the radical sign, this problem would read, what is the square root of 36? Or, what number, when you multiply it times itself, gives you 36? That number is 6. Okay, let's try another example. What if the number underneath the radical sign was not a perfect square number? Take a look at this example. What is the square root of 72? Well, 72 is not a perfect square. That means there's not a whole number when you times it by itself produces 72. But we can still take the square root of 72. Let me show you how. The first thing we need to do is we need to break apart 72. We need to factor 72 to see if there might be a perfect square inside. So we're going to take 72 over to the side, and we're going to make a factor tree. We're going to think of a multiplication problem, any multiplication problem, that equals 72. Let's try. We'll do 8 times 9. Next, we're going to continue down to the bottom of the factor tree. 4 times 2 is 8. And then 2 times 2 is 4. And we're going to drop down this 2. And then we're going to break apart our 9 to be 3 times 3. We'll go ahead and drop everything down to this bottom level. So that 2 times 2 times 2 times 3 times 3 still equals our 72. Next, because we're taking a square root, and remember the word squared means a 2, we're going to look for sets of partners in this bottom level. Okay, or I like to call them twins. We're going to look for twin numbers. For example, we have a set of twin 2's, and we have a set of twin 3's. Okay, so here's how we're going to write our answer. We're going to take our twin 2's and our twin 3's, and we're going to write those numbers on the outside of our radical sign. So because we have one set of twin 2's, we're going to put a 2 representing our set of twins times 3, which represents our set of twin 3's. Any number that's left over that doesn't have a match or doesn't have a twin to go with it, it has to stay inside of the radical. On the outside, we're going to multiply these two numbers together. 2 times 3 is 6. And then our number that didn't have a partner stays in the radical. So the best way that we can simplify the square root of 72 is to reduce it to 6 times the square root of 2. Okay, let's look at the square root of 80. Now 80 is not a perfect square number, and so we're going to have to simplify 80 the best that we can. The first thing we need to do is we're going to pull 80 over here to the side, and we're going to make a factor tree. The reason we need to find the factors of 80, that will help us determine if there is a perfect square number inside of 80. We can break 80 down to 8 times 10. 8 breaks down to 4 times 2. 10 breaks down to 5 times 2. Over here, the 4 breaks down to 2 times 2. We're going to bring this 2 down to the bottom line, bring the 5 to the bottom line, and bring the 2 to the bottom line. So that 2 times 2 times 2 times 5 times 2 still equals 80. Next, because we're looking for the square root of 80, we need to see if we have any partners of numbers in this final line. I like to call them twins. If you have any twin numbers, for example, right here we have a set of 2 2s. We also have another set of 2s. Can kind of circle them like so. So here's how we're going to write our final answer. We're going to represent each set of twins on the outside of the radical sign. So we have one set of twins, 2s, times another set of twin 2s. Now we're going to draw our radical sign, and we're going to put the number inside that did not have a partner to match up with, which is our 5. So the 5 is going to go on the inside. The last step we're going to take is we're going to go ahead and multiply 2 times 2, which is 4. And we're going to keep our radical 5. So the square root of 80 is best simplified as the 4 times radical 5. Let's try that one more time. What is the square root of 44? Take 44 off to the side and make a factor tree. 44 is 4 times 11. Then we can break apart 4 to 2 times 2, and then bring down our 11. Make sure this bottom line, 2 times 2 times 11, equals our original number. Next, because this is a square root, square means 2, and so we are looking for numbers that are in partners of 2, or we're looking for sets of twins. We have 2 2s, and so we have one set of twin 2s. We do not have anything that matches with the 11. We're going to represent our set of twins of a 2. We're going to put it on the outside of the radical, and any number that did not have a partner stays inside the radical, which will be our 11. So the square root of 44 is best simplified as 2 times radical 11. If you have any questions about this topic, please contact your professor or stop by the Math Tutoring Lab or watch this video again.